Hey everyone, in this video we're going to learn how to implement rock, paper, scissors in Python. But here's the twist. We're going to use computer vision to do this. So we're going to have a webcam that can recognize our hand gestures and figure out what moves we're playing based on those. So let's demo this just to see what it's going to look like in the end. So we see here that a window pops up and here's an active game. So it says didn't play properly because I didn't raise my hands. But in this iteration, now I can. So 3, 2, 1. And I play my plays and I get scissors and paper. So that's something that might look like an actual game. And then I might do something like that and it'll recognize those gestures as well. All right, so let's implement this. So let's create a new project and we can close out of this window here. So in order to accomplish this, we're going to be using OpenCV and a framework called MediaPipe. MediaPipe is this really cool framework built by Google. And it allows us basically to do things like hand detection, face detection, pose detection, and so on and so forth. So one of the things that is important in this is that it creates landmarks on our hands so that we can figure out where our hands currently are or where certain positions on our hands are currently at. So we can see here that later on it'll be important to know that landmarks like 8 and 12 are somewhere in vicinity of 5 and 9, and then 16 and 20 might be in a different vicinity of 13 and 17, just to figure out moves like am I playing scissors or rock, or maybe even paper when all of the fingers are outstretched. So let's get started then. The first thing is we're going to import CV2 as CV. And next we need to also use MediaPipe. So I've already installed it. I'm going to say import MediaPipe as MP. But if you haven't already installed it, if you're using PyCharm, then you can just go to the manager here. So I'll open this up here and there's Python packages. You can click that and then I've already searched for it, but just search for MediaPipe right here and you should be able to install it. I've already installed it, so it just says the version number. Now, if you haven't already installed this and you don't have PyCharm, then you can just do a pip install. So something like python 3m pip install MediaPipe. Or you could maybe just do pip install MediaPipe, whatever works for you. And there's also other installation methods that you can find online. So once we have these, we need to import these 2 lines. And then we also need 3 more lines to get started. So we need to say mp drawing is equal to mp.solutions.drawingutils. And then we need mp drawing styles is equal to mp.solutions.drawingstyles. And lastly, we need mp hands, which is the actual model, is equal to mp.solutions.hands. All right, so those are the 3 things we need, and let's get started. So the first thing is we just want to make sure that we have a stable video connection working. So let's create one. Vid is equal to cv.video capture. And then 2. 2 is the webcam that I'm using here. So that's why that number works for me. You might have to experiment with that to see which one is correct for you. Now, we can continue, so we can say width mp hands.hands. And then we need 3 parameters. Model complexity is equal to 0. And then min detection confidence equals 0.5. And then we need min tracking confidence is equal to 0.5. And let's cast this, or let's alias this as hands. Next, we can create an infinite loop while true. And inside this, we can get our frame. So ret frame is equal to vid.read. And if not ret or frame is none, if we don't have a frame, then just break out of this loop. Next, we can print this particular frame to an output. So we will say cv.imshow frame, and we'll put frame here. And lastly, we need some sort of breaking condition. So we can say cv.imshow, or sorry, we already did that. We can say if cv.waitKey 1 and 0xff is equal to or q, then we break. So this line is basically telling us if we click the letter key on our keyboard, we're going to break out of this loop. And after we break out of this loop, we can release the video. So vid.release, this will release the capture stream, and then we can say cv.destroy all windows to close all of those windows that we've opened. All right, so let's test this. We can run this here. And we should see that we get a working window. So this shows up here, and this is a blank window, and now we're going to add hands to it. All right. Now we need to add the hands, and in order to add those, we have to convert this frame first to the RGB color space. Currently it's in BGR color space, so we just want to reverse that. We can use CVT color to accomplish this. So let's say frame is equal to cv.cvt color. Our source is frame and the color space is cv.color RGB or BGR to RGB. After that, we can create our results variable, and this is going to be equal to an execution of the hands.process function. So this is currently running our model on the frame and figuring out where our hands are. And that returns the results to this variable that we've created. And finally, we can revert the frame back to its original color space by saying frame is equal to cv.cvtcolor, frame, cv.color, and this time we're taking RGB to BGR. Now that we've done this, we need to actually superimpose the hand's landmarks onto the hand in the frame. So we can do this by saying if results.multi-hand-landmarks. So this is checking if we actually have anything assigned to this. If this is not a null object, then we can say for hand landmarks in results.multi-hand-landmarks. So this is an array or a list, and we can iterate through it. And hand landmarks, each one of these is going to represent the hands that are in the frame. So we iterate through this, and we can say mp drawing.draw landmarks with parameters frame as our source, and then hand landmarks, and then mp hands dot hand connections, and then we can say mp drawing styles dot get default landmark styles, and finally mp drawing styles dot get default connection styles. So that's a lot of parameters, but this should do the job. And once we have this, we're going to see that our frame actually is flipped. So maybe we want to flip this again so that it's a mirror image of us. So we can say frame is equal to cv.flip frame 1. And that should do the job. So we can save this and let's run it. And we should see that a frame pops up. So now if I move my hands here, you can see that there are landmarks superimposed on those hands. And I can do all sorts of gestures, and it still tracks those fingers. So it's pretty cool. It's going to work really well. And we can use this to our advantage because you can see here, these kind of landmarks, like these topmost ones, when we do things like folding the hand, they get much closer to these red points right here that are at the bottom. So we're going to use that to figure out whether or not we're doing a rock or a paper being that, or scissors, maybe something like that, where we have 2 fingers folded and 2 outstretched. All right, so now that we have that working, let's break out of this and let's continue. So here's where we do the actual game part of this. So before we add anything to our loop here, we need to do a few things. So firstly, we need to figure out what kind of hand we're doing, what kind of gesture we're doing. And this is the sort of thing that's more easily accomplished or more accurately accomplishable using artificial neural networks. But just to keep this video simple, we're going to do it using just plain comparison of 2 numbers. Let's add a new function here. We'll add it on line 8. Let's call it def get hand move. And we'll take hand landmarks as our parameter. Next, let's create a variable, landmarks, and assign it to hand landmarks dot landmark. So landmark object here is the object that represents that particular point. So if we run this again, so currently it's going to be the same thing as it was before, but let's run this. And we can see here that we have all these points. In fact, we have, I believe, 21 points. So each one of these dots is a landmark, and each one of those dots is going to have a landmark object that tells us its X, Y, and Z position between 0 and 1, each of them. So we're going to use that to figure out our positions. So let's close out of this. And now here's the pretty cool part. So if we want to check whether we have, let's say, a rock. So if we go back here, if we have a rock, we're going to see that the fingers that we have, so we have, let's say 9, 13, and 17. if we compare those to the fingers that are just a little bit above, so 9, we have 12, and 16, and 20, we should see that if we're doing a rock, then the 12, the y-coordinate, should fall under the y-coordinate for 9. And same thing for 16 and 13, 20 and 17. And actually, if we run this again, let's run this code again. So if I take my hand here, so let's open the window. If I take my hand, you see this. Now, if I put it on, let's say this side, it's a little more easily visible. If I bend my fingers, you can see that these top landmarks, so this, and this, when I bend my hand, they get a lot closer to the red points until the y-coordinate actually dips underneath. Now, of course, this is not going to apply if I turn my hand like that because it's all going to be changed. But if we consider that fact that we have here, where it gets much closer and then it actually extends downward, we can use that to compare those two y-coordinates. And if the top ones are greater than the bottom ones, and the reason I say greater is because in a CV window, we go y downward is increasing and x rightward is increasing. So if it's greater, if this is greater than this, then that means we're doing rock, if all of those are. But then if we're doing scissors, only 2 of them are, only these 2. The other 2 are still above right here. And then if we're doing paper, they all should be outstretched like that. So that can be like the else case. So we can close out of this. And let's continue here. So given that we've now established this idea, let's actually bring this window here. So we want to check, if we have rock, we want to check whether this landmark has a smaller y-axis or y-coordinate than this 12 landmark, and then 13 to 16, and then 17 to 20. So that's easily achievable. We can do an if statement. If, and I'm going to use all because we're going to have 3 booleans that are going to make this work. So if all, and then I'm going to use list comprehension here, landmarks at I dot y is less than landmarks at I plus 3. So remember we had 9 and that compares to 12, and then we had, if we look here, we had 13 and that compares to 16, and 17 compares to 20. Those are all offset by 3. So we can use that to our advantage. If landmarks at any I is less than landmarks at I plus 3 dot y for I in range 9, 20, 4. So if we look back here, that basically tells us that we're starting at 9 and we're increasing by 4. So 9 plus 4 is 13, plus 4 is 17, plus 4 is 21, which exceeds 20. So we stop before that. So if this is the case, then we can return rock. Now, if this is not the case, then what if we have scissors? Well, if we have scissors, only 13 and 17 are going to satisfy that comparison. 8 and 12 are still going to have a lesser y-coordinate than 5 and 9, respectively. So let's use that to our advantage. We can say elif landmarks at 13 dot y is less than landmarks at 16 dot y, and landmarks at 17 dot y is less than landmarks at 20 dot y. Then we can return scissors. And again, I'll just pull this up here. We can see that we're comparing 13 and 16 and 17 and 20. So if those are the only ones that are bent, we return scissors. All right. And lastly, if neither of these are true, we can just assume that we have paper. So else return paper. So that's it for this function. That makes it pretty easy to determine what hand orientation or what hand gestures we're using. Okay, so now that we have this, a few more variables we need before we go back into the loop. We're going to need a clock. Clock is equal to 0. So the clock is going to help us manage the game. So if we saw our earlier program, if we remember what we did there, it looped the program every, I think, 100 or 80 frames. So we basically are going to iterate through each of these frames, just like we do in this while true loop. And every iteration of while true, we're going to increment clock. And we're going to do it in, I believe, 100 frame intervals. So we'll increase clock from 0 to 99, and then we'll go back to 0, increase to 99, go back to 0, increase to 99. And in each one of those 100 number intervals, we're going to run a new game. So clock helps us do that. And then we need our player 1 and player 2 moves. So P2 or P1 move is equal to P2 move is equal to none for now. And then we need our game text that's going to be displayed on the window. So this is equal to that. And success is equal to true. Success is basically a variable that tells us whether or not there were actually two hands in the frame. Like we saw before, if we ran the previous program. So let's just run this. And then it'll show a window here. We can see here, if I only have one hand, it says didn't play properly. And maybe if I only had 0 hands, it's going to say that I didn't play properly either. Because in a game of rock, paper, scissors, you need 2 hands. So if I had like that, then it is going to work. So we need to make sure that that is the case. So we can go back here and we have success is equal to true. Next, we need to implement the clock stuff. So after frame, we can create this long if statement or a long sequence of if statements. So if 0 is less than or equal to clock is less than 20, then we start off as success being true. So this resets the game and we have a new game. And then game text is equal to ready. Now 20 frames later, 20 frames later, we need to check if clock is less than 30. So within these 10 frames between 20 and 29, we're going to say game text is equal to 3. So this is like a countdown. And then we'll do this for 40. We'll do this for 40. And we'll say 2. And then we'll say 1. And let this be 50. And now we can say go. So elif clock is less than 60. We'll say game text is equal to go. And at this point, if clock is, or elif clock is equal to 60, here is where we need to do the hand detection. So let's call this variable HLS. HLS is equal to results.multi hand landmarks. So just to shorten that, that's all we need it for. And after we do that, we can check if HLS and length of HLS is equal to 2. So this is basically checking, is HLS an actual list or is it a null object? And if it's a list, are there 2 hands in that list? And if that's the case, we can have our 2 moves. So P1 move is equal to get hand move HLS 0. And we can do the same thing for P2 move. Now, one thing about this doesn't actually differentiate between 2 hands. So in one instance, it might think that one of the hands is player 1 and the other is player 2. But in another instance, it might flip those. So for the purposes of this program, we really don't have to care much about that. But that's just one minor inconvenience. So now that we have this, if this wasn't the case, then our program is not successful. So success is equal to false. And now we can do all the display of messages. So elif clock is less than 100. We check if success. So if success, we'll do something here. I'll just put pass for now. But if it wasn't successful, so else, we say game text is equal to didn't play properly. And that was a message that we saw before when we were testing it. Okay, so here, let's replace this. Let's say game text is equal to, and here we'll provide a message of what went on in the game. So here we'll say player 1 played, and then player 1 played P1 move. And then player 2 played, and then we put P2 move. And now we have to figure out who won. So the easiest way to check who won is first check for a tie, and then check all the player 1 winning scenarios. And if neither of those are true, then player 2 must have won. So if P1 move is equal to P2 move, then that means the game is tied. So we can say game text is equal to whatever it was before, plus game is tied. Now otherwise, if P1 move is equal to paper and P2 move is equal to rock, paper beats rock, so player 1 has won the game. So game text is equal to F game text, player 1 wins. We can copy this down, and rather than saying paper, let's say rock. And here we can say scissors, because rock beats scissors. And if this is the case, player 1 wins again. And once again, we can copy this down, and instead of scissors, or instead of rock, we'll say scissors. And instead of scissors, we'll say paper. So scissors beats paper. And again, player 1 wins. Now, if none of these conditions are true, that must mean that player 2 won. So else game text is equal to f game text, and then player 2 wins. And that's pretty much all we have to do for determining that. So now we actually have to write this text to the window. So that's a pretty easy thing to do. We can use put text to do it. cv.putText, and the source is frame. The text is going to be f. So this is actually going to be the clock, because we just want to see what the clock says. So clock, and then we'll say the current clock value, and we'll put 50/50. That is going to be the position from the top left corner. And then the font we're going to use is cv.font Hershey plain. We're going to scale it up by a factor of 2. Our color is going to be yellow, so 0, 255, 255. Again, this is BGR. And then let's say 2 here, and cv.line AA. And we can copy this down here, but this time rather than saying this string, let's say game text. And the rest of this can stay the same except for this position. Let's change it to 50/80, so it'll move down a little bit. And finally, we need to change the clock. We need to update it. And we can update it by saying clock is equal to clock plus 1 mod 100. So it'll repeat every 100 iterations of this loop. So if we've done everything correctly, that should be all that we need for this program to function. So let's save this and let's try running it. And hopefully we'll get a window that shows up here. So it looks like it's starting to work. So it says didn't play properly. And let's do one iteration here. So 3, 2, 1. All right, so it saw that I played scissors and player 2 played paper. So one of them wins. And then maybe I might do that. So paper and rock. So again, it detected. What if I do the same thing? What if I do 2 scissors? All right, both of them played scissors. The game is tied. And once again, let's say I do something like that. Paper and rock. All right, so it looks like that worked. So that was this game. So essentially, we implemented rock, paper, scissors, but using computer vision. It's a pretty nifty way of approaching this very simple game. So that's it for this video, and I hope this was helpful.